This class, we will discuss about ellipse. We will discuss about what is the definition of ellipse and critical names associated to it. Later on, we will derive the equation for an ellipse and what is the Latus rectum of an ellipse. An ellipse is the set of all the points in a plane, the sum of whose distance from the two fixed points in the plane is constant. We will come back to this definition later. First, I will explain the definition within a diagram so that you will understand very easily. Let's take two fixed points that I am referring like F1 and F2, and take any point like P1 and measure the distance from the F1 to P1. Similarly, F2 to P1 again. And let's take a thread, simply you will understand, and tie up the point at the F1, that thread, and another end of the thread you tie up at the point F2 and put your finger at the point P1, okay? Start moving thread, okay? Then it maintains the constant distance. When you move your finger, okay, the thread length is always constant, right? So that if you put the finger inside here and keep moving your finger, right? So that is a meaning that the total distance from the F1 to F2 along the point P1, that is around the point of your finger, is the constant. So let me take another point like P2 and you measure the distance between the point F1 to P2, P2 to F2, okay? So the total violet color length is same as total blue color length because we have the fixed thread. Similarly, if you take another point like P3 in the green color, the thread length is same. That is F1 to P3 plus P3 to F2 is the constant. These are total thread length, right? Okay. So if you find such a points, all the points like P1, P2, P3, if we join all together, it will form an ellipse shape. When you come to the definition, so that is a distance between F1 to P1 plus P1 to F2 must be equal to F1 to P2 plus P2 to F2. That means the thread length is the same actually, okay? So these are definition for an ellipse. Now we will read the definition of an ellipse once again. An ellipse is a set of all the points in a plane, in a single plane, the sum of whose distance from two fixed points in a plane is constant. Very simple definition, okay? Now, if we see what are the applications of this ellipse, mostly our orbit planets, right, will rotate. Earth is the ellipse shape, okay? In the aviation, the wings also is shaped as an elliptical shape. And there are the many applications in the automobiles, other industrial areas, you can see the elliptical shapes. So now we'll see the critical names in the ellipse, okay? Let's take the ellipse and these two are the fixed points. Those points are called the focus. Focus 1, focus 2. Longer distance, the wider distance where you have taken the focus 1, focus 2, right? That we are calling the major axis length. Okay, this is a major axis and this is we are calling the minor axis. Wherever intersect they both right at the center, okay, that we are calling the center of the ellipse. The major axis endpoints, wherever it is taking the turn, okay, the 2 points we are calling the vertex. But once you get familiarized, right, it became very easy for you to remember all these names. Now we will do some preparation to equation of ellipse. We need to derive the equation for the ellipse. For that, we will have some early preparation for the derivation. For simplicity, we will take the center O as our origin for the coordinate system like 0, 0. From there, half of the major axis length is A, half of the minor axis length is B, and the center to focus distance is C. Now let's equate the two things, okay? So what is the definition of ellipse? The F1C plus C2F2 must be equal to F1B plus F2B. Okay, that is the definition of the ellipse, right? So let's apply this definition. Okay, so F1C plus F2C equal to F1B plus F2B, right? That is so it must be satisfied any points along the ellipse. I just taken for simplicity one point at the C, another point at B. If you apply the ellipse definition here, okay. Now, how do you find the F1C distance here? You can see it is a rectangle triangle, right? So, this is a C distance and this is a B distance. how do we find the hypotenuse? By using the Pythagoras theorem, we can say that the distance of F1C is the square root of B square plus C square, right? And this is same as this distance from the C to F2, right? That is also square root of B square plus C square. So the total distance from F1 to F2 along the path of the C is 2 times, right? 2 times of square root of B square plus C square. That must be equal to, if you take at the point B here, see what is the F1 to B distance? You can see clearly here. From the point origin O to B is the A distance. Here is the C distance. So it's a C plus A is 1. Next is F to B. This is the distance. So this total distance A minus C is the distance, right? So this is A minus B. If you simplify it, here CC get cancelled, it will become 2A. How nice it is, you see, right? Here A is the semi-major axis length. So here 2 get cancelled. And squaring both sides, we have the very simple term here like A square is equal to B square plus C square. So here A is the semi-major axis, B is the semi-minor axis, C is the distance between the center and the focus. I just rewritten here, okay? So you need to remember this one, okay? Always in the ellipse, the total distance, the sum of the two focal distances, right? Always it has 2A, okay? A is the semi-major axis length, okay? We are defining eccentricity like C by A. C is the distance between the center to the focus and A is the semi-major axis distance. So this ratio we are calling eccentricity, okay? Now we are ready for the derivation of the equation for an ellipse, okay? I have taken the focus F1, F2 and the center to focus distance is C and the semi-minor axis length is B, semi-major axis length is A, okay? So here A comma B we are calling vertex, right? Now, if you take origin at the O, then what happened to the F1 point here is a negative direction, right? So the first will write the x coordinate and next will write the y coordinates. The x coordinate is minus C, y is 0. So F2 point is a positive C and y coordinate is 0, right? So for the equation, what you do generally, we will put any point along the ellipse, right? That we are talking like something coordinates like p x comma y point. Let's take any point p x comma y along the ellipse, okay? So the equation is always giving the relation between the x and y, right? Okay, so if you know the x, we can find the y. If you know the y, if you find the x, right? So x comma y relation we are calling the equation. We need to find some relation between the x comma y over here, right? So for that, we will join these two lines, okay? Now, basic definition of the ellipse, what is that? F1p plus P2 F2 or F2P, okay, must be equal to 2A. Why it is 2A? Since already we have seen, right, when you do with F1 to B plus F2 to B, we got it's a 2A. So now how do you find the F1P, okay, the distance between the F1 to P, distance between the 2 points. How do you find the distance between the 2 points? It is just a difference of the x coordinates whole square and the difference of the y coordinates whole square, right? Let's do that way, okay? So the x coordinates, they are x minus of minus plus c, so x plus c whole square, and y minus 0, y square root, right? Similarly, between these 2 points, x minus c whole square plus y square. So y minus 0 is the 0. So, sorry, y minus 0 is the y square equal to 2a. So these are the radical equations we got. Okay, so for solving this kind of equation, usually we'll send one of the square root term to other side of the equation, right? So we are sending this term to other side of the equation. Now we are squaring the both side of the equation. So the left side, just remove the square root when we are squaring. In the right side, it looks like a minus b whole square 1. So the a square plus b square means they just cut off the square root term here. Minus 2 into 2, 4a. This square root term again over here, right? So now what you do, all the terms will bring the left side of the equation and we will keep the square root term along the right side of the equation. Okay. So here clearly you can see here x plus c whole square, and here this side is x minus c whole square. Then x square plus c square plus 2x cx, right? So here also x square plus c square, right? That both terms will get cancelled. Only 2cx and again here minus 2cx will be there. Both adding here, the 4cx will get. And y square anyhow is get cancelled. This 4a square coming this side is minus 4a square. And minus 4a, the term is remaining the same here. Just cancelling the 4 and squaring again the both side of the equation. So we'll get the equation in the terms of the x and y, a comma b, okay. So we are trying to eliminate the c term, okay. We know that a square is equal to c square plus b square. We have proved already that, right? So from that c square, we are replacing with a square minus b square. Then how it is simplified, it you see here, okay. Then you further simplify it, and both sides of the equation we are dividing with a square and b square. Then we have the final elliptical equation. There x square by a square plus y square by b square equal to 1, okay. Now we'll see some important relations in the ellipse, okay. So what is the f1 to p distance? Is the distance between these 2 points, right? Like x plus c whole square plus y square under square root, right? We know the elliptic equation already, we derived it. What is that? X square by a square plus y square by b square equal to 1. Another one we know, right? A square is equal to b square plus c square. If you want b square term, right? A square minus c square, right? Okay, so y square term I will substitute over here. Similarly, b square also I will substitute as a square minus c square, okay, here. So here x plus c whole square as it is. The y square term, okay. If you take the y square here, see it will become like 1 minus x square by a square, and this b square terms will come here. I am just replacing this b square with a square minus c square over here, okay. And if you do further simplification over here, further simplified, we can see clearly, okay, right? This can be written like a plus c by x by a whole square, okay. That is the expansion of this one. We can see clearly. Here square root get cancelled. It will become like a plus cx by a. How simply it is coming, you see. f1 to p distance is a plus cx by a plus cx by a. Similarly, you can derive like f2 to p distance is a minus cx by a, okay. So this is a plus cx by a and this is a minus cx by a. We know that the total distance is 2a, right? If we add up these two also, the cx by a, cx by a get cancelled, and the total distance we get 2a, right? Now we'll see what is the latest rectum, okay. Already we have seen this similar word when we are seeing for the parabola equation. Here also latest rectum is defined, right? Wherever the chord length inside, okay, chord length at the focal, okay, perpendicular to the major axis, wherever the focal distance is red, like nm here. Here also written like yellow color is red. This distance is same, okay. Any of this distance we are calling the latest rectum of. You always remember it, once you derive the equation, anything you can derive very easily from the equation. Let's take our equation, okay. What is that? X square by a square plus y square by b square equal to 1, okay. It's a very simple form of the definition, okay. If you want to find this length, y length, what you do, we just substitute the x value at the corresponding to that, right? What is the x value here? Either minus c here. If you come right side here, it is c here, right? So from this equation, we just written y square equal to b square into 1 minus x square by a square, right? So here what you will do, right? You will substitute x is equal to minus c or plus c. If you substitute the plus c, you will get the right side 1. If you substitute the minus c, left side 1. It won't change actually. We will do the always squaring right here, right? X we are right doing the square, right? So if we substitute here, we get it this way. If we just take the LCM over here, it will become like a square minus c square by a square. You know that a square minus c square is a b square, right? Okay. From the a square equal to b square plus c square relation, you know already. Okay. So from there, we will substitute the b square here. That b square will become b to the power of 4 by a square. Then what about the y here? Square root of this, right? Then we get the b square by a. So finally, we got the length of the y, okay? That is from the x-axis. This is the axis, right? X-axis to this point n, okay? This is of the distance. If you want the full distance like mn, we need to do the twice, right? So that finally the latest rectum length is 2b square by a, okay? So it's a twice of this length, right? So 2b square by a. So with this, we are completing all the derivation part of the ellipse and the definition part of the ellipse. And the next class, we are going to solve some of the example problems. Okay. If you have any questions, please write in the comment section. I'll try to address that. Okay. Thank you all.